In this question, we have a 2 kg block which is lying on the wedge of angle of inclination 30 degree. The coefficient of static friction between the block and this surface of the wedge is given to be 0.2. We need to find out the force parallel to the incline, that is the force parallel to the incline which is required to move the body up the incline. So when we apply force on this object in the upward direction, what happens? When we apply the force parallel to the incline in the upward direction, first of all, it develops a tendency for relative motion in the upward direction. The work of static friction is always to prevent the tendency of relative motion. So as to prevent the tendency of relative motion, frictional force will start acting in the backward direction. Initially, there is 2g cos 30 degree acting in this direction and 2g sin 30 degree acting in this direction. First of all, this external force has to overcome 2g sin 30 degree. When it has overcome 2g sin 30 degree and becomes greater than 2g sin 30 degree, it is then that static friction feels for the first time that it needs to act in order to prevent relative motion. So when this force becomes greater than 2g sin 30 degree, then static friction acts in the backward direction so as to balance the force and to prevent relative motion between 2 kg and the wedge. Because the only work of static friction is to prevent relative motion as long as it can. If it is incapable of preventing relative motion, it will give way for kinetic friction to act, which has a constant magnitude and it acts whether or not when there is relative motion. So in this question, before the object just starts slipping in the upward direction, this force has to overcome 2g sin 30 degree and it has also to overcome the maximum static friction, that is mu s into n. Now the normal reaction here between the two surfaces is equal to 2g cos 30 degree is equal to 2g root 3 by 2, that is equal to root 3 into 10. Now we know that friction is equal to mu s into n, therefore the force is equal to 2g sin 30 degree plus mu s into n. This is equal to 10 plus 0.2 into 10 root 3. This is equal to 10 plus 2 root 3. This is equal to 2 into 5 plus root 3, which is equal to 13.46 newtons. So final answer for the amount of external force required to move the object up the incline is 13.46 newton. You need to apply at least this much force to move the object up the incline.